Welcome back. We're going to continue our discussion on concentration. We already have looked into how to calculate molarity. Okay, I might, my English is bad, so you might hear molarity and molality might sound the same, but they are not the same. So pay attention to what I'm asking. That's why I write everything down instead of just talking about it. So molality is moles of solute over volume of solvent in kilograms, all right? So our units for molality is moles over kilogram, and molality is indicated by a lowercase m. If you remember, molarity is uppercase m, which is moles over liter. Molality is lowercase m, which is moles over kilograms, all right? So here's the problem. Determine the molality. Now here's how I approach any problem, okay? Here is what you wanted to calculate. Here's what's given. You're given 2.5 grams of zinc 2 oxide is dissolved in 100 mils of water. Now if you remember, whenever we deal with density, whenever we deal with molality, this is the first type of problem, okay, which is assumed density of water is 1 grams per milliliters. Okay, I will teach you the second type of molality problem a little bit later in the course. I want you to first get comfortable with just calculating this easier version first. Okay, so what and all do we know? Okay, well, we have to find the moles of solute and volume of solvent in kilogram. That's why I actually spent time defining what a solute is, what a solvent is. See, solute is usually your chemical and solvent is usually your water. So how we find our numerator is not any different than what we did for molarity, okay? So our first job is to actually figure out the formula for the zinc oxide. The zinc is Zn, and the 2 goes with the metal, and zinc is a metal, so it's plus. Oxygen, oxide is coming from oxygen. Oxygen is 6A, so 8 minus 6 is 2, and oxygen is nonmetal. Because they're equal charge, they cancel out, so which gives us a formula of ZnO. And we have to find moles of the solute. This is our solute, right? How do we find moles? When you have grams and you go to moles, you have to go through molar mass, which is your liaison, right? So you're going to start with 2.5 grams, right? Put a 1 here, and then you put the molar mass of zinc oxide. Zinc, I believe, is 65, around about 65. So 65 plus 16 is 81, right? This is 81 grams over 1 mole, right? So the 81 grams goes on the bottom, 1 mole goes on the top, and if we solve for it, we get moles of solute to be 0.0308 moles. Now what we have done is we've just calculated this. We just calculated moles of solute. All right, well, volume of solvent is in kilogram, right? Now, our solvent here is in volume, which is milliliters. We got to go from milliliters to grams and possibly from grams to kilograms, right? The reason I gave you this is when I give you the statement, what it really means is 100 mils of water is same as 100 grams of water. What we're really meaning is the density didn't change by adding the zinc oxide to water, okay? Now, 1,000 gram is contained in 1 kilogram, right? So there's 2 ways, like I said. So 1,000 gram is 1 kilogram. So 100 grams would be 0.1 kilograms. This is one way to do it. Some people prefer this candy comparison. Some people like the block format, so I'm going to show that as well. So you've got 100 grams, put a 1 on the bottom. Again, don't put 100 mil because we've already made that conversion. 100 mil of water is same as 100 grams of water. Keep in mind, this is the first case of the problem. I will do the second case as we move further in the course. But right now, we're going to put 1,000 grams is 1 kg, so that's 0.1 kg. Well, we now know the denominator. All we got to do is solve for molality. So I'm going to start writing this way. Molality equals, which is lowercase m, equals 0.038308 moles over 0.1 kg. It's 0.308 moles over kilogram, or you can simply write it as 0.308 m. Okay, you can put the m in bracket or not, it doesn't matter, but that's how you calculate molality. As I said, this is an easier case of this problem. There's a more difficult one, but I want you all to finish learning all the concentration, get comfortable working between units, putting numerator, denominator in the right places. I want your mind to get used to this idea first. Once you're comfortable, then we will do the second case of the molality, all right? And also there's a second case for molarity as well. We'll look into that as well once you get proficient with the simpler versions, all right? So stay tuned for the next concentration topic.